Today I'm going to talk about Unit 6, Day 14, Lesson 7b, Building Quadratic Functions to Describe Situations, Part 3. Within this lesson, I'm going to focus on how we can take the instructional routine that is used for the launch and build it out to be a synchronous, engaging activity for students. And so the instructional routine that's used in the launch is based on math language routines. And the routine that we're using is the which one doesn't belong routine. This routine is similar to previous routines where it is accessible to all learners and it focuses attentions on attributes and relationships. You can read through slide 5 of day 14 to get a better idea, but there are some resources down here which can support you with better understanding how to implement and execute a which one doesn't belong routine within your classroom. And so on slide 14, you see the launch slide, which one doesn't belong, and then there's a blank, and students have to explain which does not belong and why. So in order to build this out to a synchronous lesson, I created it within a Jamboard. So the first slide is just give students the directions. Which one doesn't belong? Directions. Try to find a reason for why each one could not belong. Write your reason on a post-it note on each of the next slides. So one idea for this activity would be to give students some think time. Just give them time to think and decide which one they think doesn't belong. They can have multiple answers, but come up with at least one that they believe doesn't belong and a reason why it doesn't belong. Maybe take 1 to 2 minutes to do that. They can jot it down somewhere, type it somewhere for themselves, etc. After giving them that think time, you can then put them into breakout rooms. And the instructions can be that during this time you're going to go into breakout rooms, you will collaborate together, share which one you believe didn't belong, and your reason for why it did not belong. As a team, your responsibility will be to come up with a reason for why somebody could say that each one does not belong. Okay? Then you can even assign each group a color post-it if you prefer to do it this way. And on Zoom, so when you do breakout rooms, if you are going to create breakout rooms and let participants choose room, I usually let them choose. Well, no, for this, I would assign automatically. And I would press create. And then you can rename. So room 1 is the pink post-it room. Right? And so when you assign them to their room, they will be able to see that they're in the pink post-it room. And you can even have a slide that kind of shows them that before they enter. Another thing you could do, actually, is you could even put on here, this is room 1, and this is going to be the pink post-it, right? And just put it on here so they can visually see that as well. Okay. So then once you put them into breakout rooms, and this is not the only way to execute this. You do not have to use breakout rooms. You could also just do this activity that I'm going to show you, and students can just do it in independently. And so they'll go in breakout rooms. They'll each be responsible for a post-it color, and they'll have to come up with the reason on that post-it why each one doesn't belong. And so I kind of mocked up some examples of what that might look like. Okay, so if we're looking at why A does not belong, some students might have said it's a horizontal line. It's the only one with no rate of change. This is the only graph where the y values don't change. It is the only line with a 0 slope. Some might have more reasons than others. And it's okay if not every group has a different reason. It's okay if students want to use the pen and agree with another group. It's okay if students want to use, just rewrite the same, the orange group, maybe they want to just rewrite the same reason on another sticky note. That's fine. Okay, we might not have a lot of different reasons. And so when reviewing this, because this lesson is really focusing on key features of graphs, we might really want to hone in on that y-intercept, right? The change in the y values. So this is the only one where there is no change in the y values. The y values aren't changing. We have a 0 slope, no rate of change, right? And we might bring students to kind of start to see that. What does it mean when the y values don't change? It means we have a 0 slope. It means it's a horizontal line because it's not growing. It's not increasing or decreasing. Okay? And so then if we go to B, this one might not belong because it's the only increasing linear function. It's the only linear function that's actually growing. It is the only graph where the y values increase at a constant rate, right? So in this one, the y values weren't growing. In this one, the y values are growing at a constant rate. And again, this one might not have 5 responses, and that's okay if we're just checking off an agreement or if, the groups wanted to put Post-its up. And so you come back together and you're just going to share out and kind of debrief and notice the connections and notice how it's the only increasing. It's the only graph where the y values increase at a constant rate. Well, that's a very similar response. This one's a little bit kind of disconnected from the root of the lesson, but it's an observation, and it's a true observation. And so we're going to recognize it, accept it, and bring it into the conversation. And then in this graph C, somebody might really use this vocabulary, right? It's the only discrete function. It's not continuous, like beautiful use of vocabulary, making connections. But somebody might just say it's not connected, and that's okay too, right? We're accessing at all different points. Somebody also noticed it grows the fastest. How did you know it grows the fastest? Where do you see that happening? Okay. And that's because at 1, right, it's at the highest point compared to any other graph. What about the graph creates a space for it to be growing the fastest? What type of function is this? What type of function is this? These two are the same type of function. What's the difference between them? And so because it's an exponential function, it's growing quickly, more quickly than a linear function would be, whereas this function's not growing at all. And then for the last one, the main point is it's the only graph that does not intersect 0, 2. It's the only graph with a different y-intercept, right? It's in having a y-intercept up here. And so again, it's an exponential function. So it could even be the only exponential function that's not discrete, right? There are a lot of different reasons students can come up with, but it's okay if some groups are unable to come up with any reason for each one. That's okay. Some of them might be really like hone in, like there are some that are more obvious or more that might draw you to them more quickly, right? Like this one is one that a lot of students are just going to say, oh, it's the only one that's horizontal, not growing. And that's okay. And so you're going to use this discussion of noticing the y-intercept difference, noticing the growth in the y value, the differences between the growth and the y value. Even noticing here how it's discrete and maybe its domain does not include fractions. Well, it does include fractions, but because we see it going right here, but its domain might have a certain restrictions. And so we'll talk about that and we'll connect that to the lesson. Okay, so in summary, which one doesn't belong is an opening warm-up launch strategy that is created to give students multiple access points to the content that we're going to be discussing in the lesson, gives them a space to think creatively, think collaboratively, and really just analyze the math and representations that are in front of them. And again, you do not need to look for one's particular answer. You can accept answers of all different kinds as long as they are mathematically accurate. And if they're not mathematically accurate, if somebody says this is a linear function, we want to notice that response and then talk about it. Why isn't this actually a linear function? Or what made you think this was a linear function? What makes something a linear function? How can we check if that's valid? Right? It has to have a constant rate of change. Does this graph have a constant rate? Let's compare some different points and notice. Okay.